This particular lesson is on applications of the normal distribution. In the last lesson, we learned how to find area under the normal curve using the z, both the positive and the negative charts. Today, we're going to see how to apply that. So before we begin, let's first remember the z-score formula. It states z equals x minus mu divided by sigma. In other words, we take the data value minus the mean and divide by the standard deviation in order to find the z-score or the standard score. Here's the first example that we're going to work through together. It states a survey by the National Retail Federation found that women spend on average $146.21 for the Christmas holidays. Assume the standard deviation is $29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed. Okay, let's first go ahead and draw out a picture of what this would look like. So we have a normally distributed data set where the mean is $146.21. So we're placing that in the exact center of that distribution. The standard deviation was said to be $29.44. I'm just writing that off to the side so I don't forget. And then the question, or what we want to try to find, is the percentage of women who spend less than $160. So thinking about where 160 would fall on this distribution, it is going to be to the right of the mean. So I'm just going to place a line to the right of the mean and label it 160. We want to find the area that's to the left of that. In other words, the women who spend less than $160. So I'm shading to the left. Let's go ahead and find the z value that's associated with that value of 160. So we're using the z-score formula. We're going to take the data value, 160, subtract off the mean, $146.21, and divide by the standard deviation of $29.44. That's going to give me that z-score that's associated with that line of $160. Okay, I went ahead and calculated that off to the right in my calculator, and I'm rounding this z-score to 2 decimal places because that's how the charts are read. So 0.4, and I'm going to round that to 7. Okay, we're going to go ahead and look up that z-score on the positive chart. So if I look up in the first column 0.4 and go across to 0.07, I see 0.6808. 0.6808. That is the area to the left, which is exactly the shaded region that I want. So there's no additional steps that I need to do in order to find the probability. If we wanted to, we could round that to a percentage. So 68.08% of women spend less than $160 for the Christmas holiday. Okay, we're going to go ahead and take a look at a second example together. It says, each month, an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the standard deviation is 2 pounds and that the variable is approximately normally distributed. If a household is selected at random, find the probability of it generating between 27 and 31 pounds per month. Okay, so let's go ahead and again draw out this distribution. So we have the normal distribution centered at 28 pounds. That's the mean. Our standard deviation is given as 2 pounds, and we want to find 27, which is on the left side of the mean, and 31, which is on the right side of the mean, and we're shading between them. So we actually have two values, two z-scores that we have to find. The z-score that's associated with 27 and the z-score that's associated with 31. So using that z-score formula, we're going to first transform the 27 minus the mean of 28 divided by the standard deviation of 2. And then we're going to transform the 31, again, both into z-scores. So if we do that math, our first z-score is negative 0.5. And this one we would get a positive 1.5. Okay, so we're looking for the area between a z-value of negative 0.5 and positive 1.5. I'm going to go ahead to the positive distribution first. Looking up, the z-score of 1.50 is 0.9332. That would be from this line of 1.5 the whole way down to that left tail region. Okay, and now we're going to look at the negative distribution for negative 0.5. So if I scroll down, negative 0.50, I see 0.3085. 0.3085. That would be from this negative 0.5 line to the left. So you see, we actually want to get rid of that probability. So I'm going to subtract the 0.3085 from the 0.9332. Okay, I get 0.6247 as that probability. So again, I could change that to a percentage if I would like. So 62.47% represents the probability that a household is going to generate between 27 and 31 pounds per month. Okay, the third and final example that we're going to take a look at together says the American Automobile Association reports that the average time it takes to respond to an emergency call is 25 minutes. Assume the variable is approximately normally distributed and the standard deviation is 4.5 minutes. What is the probability that a call will take more than 15 minutes to respond to? Okay, let's go ahead and draw this one out. I'm going to place it above here. We have a normal distribution centered at 25 minutes. We want to find the probability that it'll take more than 15 minutes to respond. So 15 falls to the left of the mean, and we want to find the area above it. Standard deviation is 4.5, so again, I'm just placing that off to the right. All right, let's convert that 15 into a z-score. So the data value of 15 minus the mean of 25 and divided by the standard deviation of 4.5. That gives me a difference of negative 10. And if I divide that by 4.5, I get negative 2.22. I'm going to go ahead and look that up on the negative z chart. So negative 2.2 and across to 0.02, I see 0.0132 as the probability. 0.0132. That is from negative 2.22 z-score and to the left. But notice that's not the area that I want. I want the area to the right of it. So thinking back to that last lesson, I'm going to have to subtract this area from 1 to get the area of that shaded region. So if I do that, 1 minus the 0.0132 will give me an area of 0.9868. Or if I turn that into a percentage, 98.68% of calls will be answered in 15 minutes or more. Notice that there's a second question to this scenario. It says, if 80 calls are randomly selected, approximately how many will be responded to in more than 15 minutes? So I know 98.68% of those calls are going to take more than 15 minutes to respond to. So I'm just going to multiply 0.9868 times 80. So in other words, I'm finding 98.68% of 80, and of means multiply. So if we do that, 0.9868 times by the 80 calls, it looks like 78.94 calls, or approximately 79 calls, will take 15 minutes or more. Okay, this next example is a U-try. So read through this scenario, pause the video, see if you can find the probability, and then unpause the video to get the results. Okay, here are the results of this U-try example. First of all, I drew out the distribution, centered it at 82,000 with a line to the right of 83,500. I transformed that 83,500 into a z-score by using the z-score formula here to the right. I got a z-value of 0.3. Looking that up on the positive z-chart, it is associated with the area 0.6179 to the left. We wanted a greater than scenario, so I had to take 1 minus that value to get a final probability of 0.3821, or 38.21%. All right, this concludes the lesson on applications of the normal distribution.